Yeah, geometry in the middle school and only slightly covered. Many students are not even prepared when they get in the high school. Okay, different schools, they really cover different material on geometry, and there's no uniform textbook in the United States to cover those topics. So in middle school, you only heard about algebra 1, algebra 2, right? Or pre-algebra, but very few schools probably offer a specific course on geometry. But that's required. And if you look at the math contest and all the topics covered, okay, and that's required, okay, that's a standard set by all, this Department of Education. But each school has freedom to choose their topics. Yeah. So I'm going to talk about, this is the second lesson on geometry. And this is about the angles in polygons. Okay, first of all, what is angle, right? How to measure the angle? Well, angle, this is angle, right? If I just write like this, you say, well, this is angle. You're not between this. Okay, it's big or small. Then sometimes you can compare, but you need a measurement to measure the angle. Okay, and how to measure it? Okay, we have to choose a unit. Okay, we have to choose a unit, and we decide that there's two different ways to measure the angle. We decide, yeah, this is you rotate to this side counterclockwise, okay, and for the whole complete circle, that would be 360 degree, okay, that would be 360 degrees. Then use that to measure the angles, okay. So the complete circle will be 360 degree. Then then you divide by 4. Okay, divide by 4, right? The complete circle is 360 degrees. Okay, 360 degrees. So divide by 4. This will be 90 degrees. Okay, and so 90 degrees is a right angle. We also call the right angle. Okay, that's the measurement. And then you can also divide the 90 degrees. This is 90 degree, right? So 90 degree, and divide them into 3 equal parts. Then that will be 30 degree, right? 90 divided by 3 is 30 degrees. So this is 30 degree. So you get some ideas of how big of the angle. All right. Now in geometry, we have names called the complementary angles and the supplementary angles. Okay. So if you have two angles, if alpha plus beta, these two angles, if those two angles, the sum is going to be 90 degree, then they're called complementary angles. So if the sum of those angles is 180 degree, then we call them supplementary. Okay, so here's a picture. Okay, you have two angles. This is alpha, this is beta, and this is 90 degree. Alpha plus beta is 90 degree. So this is another one. And here's alpha, and that's a beta. Add them together. So beta is larger than 90 degree in this case. So alpha plus beta is 180 degree. And those two angles are called the supplementary angles. Okay, those are the names. And there was an important formula we discovered. Okay, in the plane, okay, we find out. Okay, this is polygon. Okay, many sides. This is called convex polygon, and this is another convex polygon. Okay, there are many sides. Okay, but so we're going to do is we're going to rotate the counterclockwise. We extend this line and rotate this called beta 1. That's beta 2. That's beta 3, and then beta 4, and so on. Okay, so we find out the sum of exterior angles is always equal to 360 degree. Okay. Yeah, so it's always have 360 degree. It's independent of the number of the edges. Okay, independent of the number of edges. Okay, that's interesting, phenomenon. Okay, let's look at the special case. The special case is a rectangle, and you will see that this is 90 degree, right? 90 degree, and the 90 degree, and the 90 degree. So add them together, 360 degrees. Okay, and the hexagon, for example, the right hexagon, let's call it hexagon. Okay, how do I figure out the exterior angle of the right hexagon? Okay, the right hexagon, some of you probably know that if it consists of many equilateral triangles. So that would be 60 degrees, that would be 60 degree, right? And that exterior angle will be also 60 degree. Okay, and the 60 degree, okay, how many right exterior angles here? How many exterior angles? 60 degree have a 6 exterior angles, so 360 degree again. That's the sum of the exterior angle. Okay, so doesn't matter how many edges you're going to have. How many sides do you have? The sum of exterior angle is always 360 degrees. That's there. But this is not always true on the other surfaces. Okay, on the hyperbolic surface, on the sphere, that's not true. Okay, think about this is this fact is not true when it's on the other surface, like a sphere. Okay, this is not true on a sphere. Okay, this is not true on the sphere. And for example, I'll give you a sphere, right? And this is equator, okay? And this is a great circle, and another great circle, okay? So now you get a triangle. The vertex is at one of the vertices at the, yeah. So then we make sure this is a perpendicular. So here's a 90 degree, right? And then 90 degree, right? And this is also 90 degree, right? What do you get? The sum of three exterior angles is 90 degree plus 90 degree plus 90 degree is only get 270 degree, okay? Which is less than 360 degrees, okay? Yeah, imagine you cut the ball, okay, sphere, first along the equator here, then another equator, right? Just like a cut a watermelon. Then also cut another one here, so that these two are perpendicular. This is all perpendicular, right? So then exterior angle is 90 degree. Even interior angle is also 90 degree, right? Yeah, so interior angle is 90 degree. That's interesting. Interior angle is 90 degree. So sum of three interior angle will be greater than, is also going to be 270 degree. Okay, anyway, so the above fact is not true on the sphere. Okay, so that's called a spherical geometry. We are not going to study here. We only study plane geometry. We are studying plane geometry. Okay, we only work on plane geometry. Okay, so now we have the general fact, right? Exterior angle. How about the interior angle? Okay, this is the exterior angle. Okay, beta 1. Beta 2, and this is the interior angle, right? Alpha 1, alpha 2. Here's the beta 3, that's alpha 3, okay? And so on. So the interior angle plus exterior angle is always going to be 180 degree, right? 180 degree. So now you add them together, you have n sides, right? 180 degree, right? You have n side. Add them together. I suppose it's an n polygon. Yeah, we're trying to derive a formula, right, for the sum of the interior angles. Okay, polygon. Okay, n polygon means n sides. I add them together. Okay, Here I have alpha 1 plus alpha 2, alpha n. This is sum of interior angle. And the other side is beta 1, also beta n, because n times 180 degree. Okay, we already know this is a 360 degree, right? The sum of exterior angle. So then you conclude that the sum of interior angles, and is going to be, and then it depends on how many edges do you have, right? So it's 360 degree plus n times 180 degree. So I'm going to move this term to the right-hand side. And then I get minus 2 times 180 degree. So I can take 180 degree out. So n minus 2 times 100 degrees. So this is another formula for the sum of interior angles, but now this time it depends on the name of the edges. Okay, for the triangle, how many edges does the triangle have? N equals 3. So you have 3 angles, alpha 1 plus alpha 2, alpha 3. And 3 times 3 minus 2 is 1. Okay, so the triangle, the sum of the 3 angles is always equal to 180 degrees. Okay, that's a very important fact. Okay, this comes from what? Comes from the formula, comes from the fact we prove that the sum of exterior angle is going to be 360 degrees. Okay. All right, let's do the following exercise. I have a triangle. Okay, this is a alpha, that's a beta, 2 interior angle, and this is a gamma. Gamma is the exterior angle. One of the exterior angle shows that gamma equals alpha plus beta. How do we know that? You have to give proof, right? Now, in general, in the school, we don't do proofs. Okay, that's why the students lack of the training improves things. So once they get to the college or some high levels, and once you get to prove problems, you have to prove some things, and you gotta be lost. Okay, so that's training. Is like if you ask your parents already learned that when they're in the middle school. Okay, how to prove things. So we are going to prove that this exterior angle is going to be sum of the 2 interior angles opposites on the on the other side. Right? So let's do it. How can I prove? Well, it's very simple to prove. Right? Write down the word proof. Okay? Then you figure out the interior angle. So this interior angle is going to be 180 degrees. So by the theorem, alpha plus beta plus another interior angles, which is 180 degree minus gamma, this should be equal to 180 degree. Okay, now after write down this, then 180 degrees canceled out, right? Then you get 0. So that means gamma equals alpha plus beta. Then that's the end of the proof. Very simple. All right, our next problem, we're going to use a formula, okay? Each interior angle of a regular polygon measures 180 degrees. How many sides does it have? Okay, we don't know the numbers of sides, but I measure each interior angle of a regular. Now, what do I mean regular? Regular means all the sides have the same length, okay? Measures 144 degrees, okay? How many sides? Right? No. Kevin says why? The angle C has to be 90 degrees. No, necessary. I just draw it. It looks like a 90 degree, but it's not 90 degree. Okay, this picture can be like that, comma, alpha and beta, okay? So gamma is going to be alpha plus beta. Okay. All right, now, yeah. So we don't know how many edges does this have? How many sides does it have? Okay, so polygon, right? Polygon. So let's say n sides. It has n sides. Okay. So the sum, each interior angle is 144 degrees. If it has n sides, that means it have n angles, right? So the sum of the interior angles, okay, because it's regular polygon means all the angles are the same, right? So I have a 144 degree times n, because you have n angles of the same measurement, right? And on the other hand, by the formula, it is going to be n minus 2 times 180 degree, right? So now you have to solve for n, right? You have to solve for n. This is going to be, right, 144n equals 180n plus 360, okay, without degree here. So you move this term to the right-hand side, okay? You will get 36, n equals 360, n should be equal 10. And so it has 10 sides there. Good, good. Now, if you have the answers, post to me privately. You just click the host and post it. Okay, you don't need to disturb us. Okay, so this is how do we solve the problem. All right, our next problem I wanted to try is that we know that there's a 3 angles of a triangle are in the ratio 2 to 5 to 8. What is the largest angle? All right, so please work on this. Right, yeah, thank you. Yeah, Ethan Chen, the names. Right, so Ethan, if you get answers, please let me know, okay? Okay, Lala does pretty fast. I wish you stay in this class, okay? I saw you registering another class too. All right, so the geometry is calculus, this course.
I think the last answer was, I think the last answer was 15.
You think the last answer is 15? Let me check. Did I make a computation mistakes? No, the last answer is 10. Okay. It was if interior angle is 140 degree, now 140 degree plus times n, that's a sum of interior angles. And then should be n minus 2 times 180. So you just solve this equation. All right. So you get 36 equals 360, n equals 10. I do see Kelvin got 15. All right. But let's look, yeah. 10 is the right answer. Okay, as long as the equation is correct, okay, then you should get the same answer. All right, so now, now you look at this problem, right? The three angles of a triangle are in the ratio. Now, how do you deal with the problems with the ratio? This is the algebraic problems, okay? Ratio 2:5:8, what you can do is, you don't need to even draw the picture here, okay? What happens? My screen's a freeze. Okay, let me double check. All right, so you get the number, the angle is can be 2 to the lambda. Yeah, let's move it here. Yeah, 2 2 lambda and the 5 lambda and the 8 lambda. Those are three angles. We don't know the value of lambda, but we know the sum is going to be 180 degrees. So you find the value of this parameter. Okay, so you add them together. 2 plus 15 lambda equals 180 degrees. So lambda is going to be 180 degrees minus divided by 5. Okay, and so after you simplifying, this is going to be this is going to be 12 degrees. Okay, now if you use a degree, yeah. Well, if I use depends what measurement you're going to use. Okay, so then the largest angle is 8 times lambda. So 8 times 12, and that is going to be 90-60 degrees. Okay, so Lala got the answer, and I did not get the answers from the rest of you. All right. Okay, now let's work on the next problem. We know isosceles triangle, right? Isosceles triangle. Okay, this is a Greek name. Okay, isosceles triangle means these two angles are the same. Okay, so we have an angle here, triangle, and B and C. I'm going to draw a line perpendicular to this side, and that point denoted by D. Okay. So what I know here is if this is a 40 degree. Now find the angle DBC. Where's the DBC? Find this angle. Okay, I call the X degree. So what is X? Okay, so let's work on to this. I wanted to try first. Okay, if you get the answers, please post to me, okay, privately, so I can know you figured out. Great, I have one answer is correct, I guess. Okay, how about tennis? Yeah, quiet. Tennis, are you there? Right. Oh, at least you're there. Okay. So you see, look at this triangle, right? We have to find a way to solve it. We call it two-step problem. So what I'm going to do is I'm going to focus on this triangle, okay, in the yellow color. Step one, I have to figure out the angles at the point C, okay? At angle point C, we call it, let's call it y degree, okay? So that means a 40 degree plus y degree, because I saw triangle, so plus y degree equals 180 degree. So you find that y first, okay? 2y degree is going to be, 140 degree, right? 80 minus 40. Then you multiply by 2, so it's 70 degrees. So y is 70 degree. Then inside this yellow triangle, right triangle, right? X degree, X and Y are, we call it complementary, right? So X degree plus Y degree should be equal to 90 degree, right? We'll add them together, right? That's the right triangle. For the right triangle, yeah, this is always true. So X degree is going to be, right, 90 degree minus 70 degree, which is 20 degree, okay? So that's called a two-step problem. Step one and step two, right? Here, the factor we're using here is the sum of the three angles is going to be 90 degree, is going to be 180 degree. But for the right triangle, if this is the right triangle, this is alpha, this is the beta. Then because alpha plus beta plus 90 degree is going to be 180 degree. So therefore, alpha plus beta is always going to be 90 degree for the right triangle. Okay? For the right triangle. So we just only use one important factor, the sum of three triangles, sum of three angles. The triangle is going to be 180 degree. All right. So I'm curious about the hexagon, right? I remember the hexagon. Sorry, the polygon, right? Yeah, hexagon, the right hexagon. The right hexagon, what is the interior angle? Yeah, find that. Yeah. So what is alpha, right? We solve this problem directly, right? So you have a 6 identical angles, so 6 times alpha. This is the sum of the interior angle, right? It's going to be 6 minus 2 times 180 degree. All right, why is the sum of the interior angle? So that means alpha is going to be 110 degree, because this is 6 and 4 times 180 degree, right? And then alpha is going to be 4 times 180 degree divided by 6. And you simplify it, and that is going to be, yeah. And that is going to be 120 degree, right? You can simplify this, like this is 2, here's 3, and 360 degree, right? So 120 degree, okay? And you can get that using using 6 identical equilateral triangle. Yeah, you can also get this. And how do you see that? You see? Because, okay, first of all of them are isosceles triangle, and you get, this is alpha, right? So let's look at the beta. So every angle is the same. Okay, beta is going to be 360 degree divided by 6. Okay, so 60 degree. But then this is a isosceles triangle. So that means if this angle is half of alpha, right? So that means beta plus half of alpha plus other angle, half of alpha, is going to be 180 degree. Okay. So from here, you can get the beta plus alpha equals 180 degree. And the beta is already now 60 degree. And then alpha is going to be 120 degrees. So that's another way to figure it out. So there are many ways to do that. All right, so what I want to do is I want to draw a right 5-star. Okay. I wanted to find this angle alpha. Okay, this is a right 5-star. It's right 5-star. Right 5-star means all the 5 angles are identical there. From you look at this from any angle, right? They're all same. Okay. Okay, Kelvin gave me 60, Lala gave me 36 degree. Anyone else? Canis, I call your name again. Canis. Yeah, regular 5. Yeah, it's called the 5-star. Okay, so that means they are all those angles are the same. All right. Okay, let's see. Now, if you can notice that this is a right hexagon, then you solve the problem immediately. Okay, so let's how to do that. So this hexagon, so this is a 120 degree, right? So the other side also 120 degree. Now you focus on this triangle. Okay, where 120 degree, this is alpha, we don't know, right? And this side is also 120 degree. Okay. And if this is 120 degree, then what is that angle? That angle is 60 degree, right? Right? 60 degree. Yes or not? Okay, but that's not 120 degree. This is a pentagon, not a hexagon. Yeah, it's a pentagon. It's not a hexagon. So if it's a pentagon, let's figure out the angle, okay? That's not a pentagon. Yeah, it looks like a hexagon, but to make sure the 5 sides, so I'm going to call it beta. Okay, so 5 times beta, the sum of the 5 interior angles, is going to be 5 minus 2 times 180 degree. Okay, so that means 5 beta equals 3 times 180 degree. So beta is going to be, right, you divide by 5. Okay, let's try. Okay, then yeah, then you get let's do the calculation, right? 3 times 180 divided by 5 is 108 degree. So that is 180 degree, not 120, right? 108 degree. So now you have a picture here. 180 degree this side 180 degree. So this angle will be 72 degree, and this is alpha, we don't know, right? So alpha plus 72 degree plus 70 degree is 180 degree. That's all two-step problem. Right, so alpha is going to be, right, 180 minus 72 minus 72. So that's going to be 36 degree. Right, 36 degrees reason. Right, answers. Great. All right, so now let's look at the next one. So what I'm going to do here is I draw a rectangle. I don't know how long is this rectangle. That's a rectangle. Then I pick up a point here, somewhere. Then I draw the line. Right. What I know is this side is a 50 degree. I find out. So here's alpha. Here's beta. Right. Of course, alpha beta cannot be uniquely determined. Can we determine the sum of those two angles? So this is a rectangle. So, you know, the alpha beta are not uniquely determined, clear each individual, but maybe the sum can be uniquely determined. Okay, how do you do that? Yeah, all you needed to do is find a polygon, and then the sum of the interior angle is going to be 360 degrees, right? It's 4 sides. Then you solve the problem. Okay, that's my hint. So please work out this. Right. Well, you're pretty silent here. Lisa. Well, when you get an answer, okay, Calvin, you look at the picture. Do you think it's reasonable? Of course, I did not draw the picture, the scale, right? Maybe that angle does not look like a 50 degree. All right, so I'm going to show you, okay? So you can consider this bigger one This is a 50 degree. And what is the angle? Alpha plus 90 degree. What is the angle? Beta plus 90 degree. What is the angle? 90 degree. Add them together, right? 50 degree plus alpha plus 90 degree plus beta plus 90 degree should be equal to 4 sides. So 4 minus 2 times 180 degree. Okay, and this side, this is going to be, 360 degree, right? So you have a 90, 90, 90, and then left is 90 degree. So 50 degree plus alpha plus beta equals 90 degree. Okay, so alpha plus beta is going to be 40 degree. Okay, so that's it. All right, let me show you another picture. Okay, so this is a picture, okay? A, B, C, D, E, F. Okay, I'm going to mark all the, so A, B, C, and the A, D, F. So this is alpha, that's a beta. So I know alpha plus beta is going to be 40 degree. Okay. Can we determine the angle? BED, okay, this is the angle I called X, that triangle called Y. So find X minus Y. Wow. Okay. All right, that would be, of course, a bit two-step problem. Now you have to, eventually you have to focus on one triangle here. Okay. Okay, my hint is I'm going to denote this angle by gamma. Okay. So here's my hint. X is gamma plus beta. Okay. Remember, this is the, if you have a triangle like that, right? Right, if this is a, yeah. So let's draw the picture here. If this is a, this is X, this is a beta, and this is gamma. So X is going to be beta plus gamma. All right. Nobody gave me the right answer. I needed to know the value. Okay. So first of all, x is going to be gamma plus beta, but the gamma is going to be alpha. Gamma is going to be y plus alpha. You know why? Because look at this triangle. Okay, this is alpha, this is gamma, and this is gamma, right? So gamma equals alpha plus 1. So after you plug into here, so x equals y plus alpha plus beta. So that's why x minus y is going to be alpha plus beta. Okay. So that's why if you know the value for alpha, that's going to be the sum, that's going to be 40 degrees. Okay. Yeah. Okay. So that's the answer. All I have to do is just prove this identity always true. Using the fact, right? The exterior angle is going to be the sum of the other two interior angles. Right. So yeah, but this one is more direct computation. Let's see. I draw the picture here. Okay. I have to draw a little bit different. Okay. All right. So A, X, Y, B, and C. Okay. What we know is AX equals XY equals YB equals BC. So that means all those sides are equal. Okay. Oops. Yeah, all those sides are equal. Okay, all those sides are equal. I know the angle at the point A is going to be 10 degrees. Right? I really want to find the angle here at the bottom. I want to find the angle, this angle. Okay. So find the angle C. So my hint is you focus on the three triangles, one by one. Okay. And you figured out all the angles step by step. Then you finally get the angle C. Okay, that's my hint. Okay, let's finish it. Okay, step one, because this is isosceles triangle, I get 10 degree, right? Step two, I know this angle, right? I know this angle, right? So this angle will be 20 degree, right? Because and this angle will be 160 degree, okay? Step by step. And then this will be 20 degree, right? Now once you get this angle, then I can get the angle. 20 plus 100, 140, so get 180 degree. Okay, once this is at 4, then I can figure out the other angle. It's because 10 plus 140 is 150. 150 plus 30 degree get 180 degree. So finally, this angle should be 30 degree. Okay? Just step by step in the sequence. Yeah, then you get the 30 degree. Our next problem, yeah, I have a polygon in a hexagon. Okay, in a hexagon, it's hard to draw it. In a hexagon, okay, the angles at the vertices are denoted by alpha 1, alpha 2, alpha 6, right? Okay. I know if alpha 2 minus, this is arithmetic sequence, okay? And so alpha 3 minus alpha 2 and so on, alpha 6 minus alpha 5, it's going to be 10 degrees. So this is a arithmetic sequence of the 6 angles. So I want you to find out the largest angle, alpha 6. Right, so the angles increase, one by one, right? Angles increase. You begin with, I don't know the first angle, how big is the first angle, right? Yeah, it's hard to draw the picture. Yeah, I just sketched the graph. I hope you can get, yeah, I hope you can get alpha 1, alpha 2, alpha 3. Right, it's greatly increased. So that means you begin with the first angle. Every time you get 10 degrees more, 10 degrees more. And the second one, you increase a little bit, increase a little bit. So you got the idea already, right? Okay, you can write the angle in the following way. Alpha 1, I call the alpha, okay? So alpha 2, I call the alpha plus 10 degrees, increased by 10. Alpha 3 is alpha 2 plus 10, so, and it's 2 times 10, right? Yeah. Alpha 4 is alpha plus, you add another value, 3 times 10. Add 10 to alpha 3. So alpha 5 is going to be alpha plus 4 times 10. Alpha 6 is alpha plus 5 times 10. So those are the angles, the sum, right? The sum, get them together. The sum is alpha 1 plus alpha 2, alpha 6, right? Add them together, you have 6 alpha. And how can I add all those together? Well, you have 1 plus 2 plus 3, right? 1 plus 2 plus 3 plus 4 plus 5, and times 10 degrees. Okay. We know that the sum of the interior angle is 6 minus 2 times 100 degrees. So from here, you will get, okay, so let's figure out what is this, right? 1 time, yeah, 6, and here's a 15, right? So 6 plus 4, 10, 10, 10, yeah. So you get alpha first, okay? You get alpha first. So 6 alpha is going to be 4 times 180 degrees, right? Minus 15 times 10 degrees. And you do the calculation, and then you get answers. Okay, so 4 times 180 right? Minus 15 times 10, right? Then you divide by 6, right? That's 95. Then once you get alpha, the smallest angle, then get alpha. The largest angle is alpha plus 50. So 95 plus 50. Okay, so it's 145 degrees. I hope you get this. All right, so this actually is not a really geometric problem. We use the fact that the sum of interior angles is going to be 6 minus 2 times 180 degrees. So this is a sequence problem on a sequence. You get the arithmetic sequence, a sequence, yeah. If we have a sequence A2 minus A1 equals A3 minus A2, right? All the way right, so equals A, then you can express each term using the first term and the last in the A, right? So you can A3 equals A1 plus A2. Just add the 1A to the previous term and keep it going. AN is going to be A1 plus N minus 1 times A. So you get the general formula. And depends on the first term, and there's a difference of those consecutive terms. Okay. And you can also find the sum of all those terms. Okay. Okay. You can add them together. And what is the sum, right? A1 plus A2 all the way to AN, right? Then what you get here is going to be, you see, you add the A1, right? So add all together, you can have A1 equals A1, right? Add all together this side. Okay, that's going to be how many terms do you have? N times A1. And then you have a 1 plus 2 plus 3 all the way to N minus 1 times A. Then you simplify it. And you get N minus 1 times A divided by 2 times A. So this is a formula for the sum of the N terms. Right, so that is about problems on sequences we learned the last semester. I'm going to stop here.